Alrighty, welcome back. Okay, so last lesson we were looking at the interest rate. 2 lessons ago we were looking at finding the principal, the starting amount. Now we're going to be looking for the number of compounding periods. Now, it's very different from the other ones. And the reason it's different is the first two we solve algebraically, meaning we go through and we have to do the same thing to both sides to solve our answer. For compounding periods, it's different. The best method known to solve a question like this is guess and check. But there's a good way to guess and check and there's a bad way to guess and check. And I'm going to go through the best way to guess and check so that we make sure we're not just wasting our time, because guessing and checking can, for some people, take a long time. So it's about setting it up, planning, so that we don't make any silly mistakes. Let's have a look. So what do I mean by solving for the compounding periods? Okay. Well, let's see, I've got $6,000. I want it to turn into $7,000. And I know that I can get 4% from the bank per annum, compounded yearly. Okay. Question is, how long is it going to take for $6,000 to turn into $7,000? That's the question we're trying to answer. So I'm looking for my n. Well, let's start off the same as we always do. Label our variables, substitute into the formula. Okay. So what I have on the right-hand side is 6,000 times 1 plus 0.04 to the power of n equals $7,000. My goal, find out what n is. So, what am I going to do? In my calculator, I'm going to write something that looks like this. Right? You see I've left a nice little blank spot up there for where n will go. Just using my little hat button. So now I can just type different values in. And what most people do is this. They go, let's try for 5 years, go equals. Hey, that's too much. Let's try it for 4 years. Okay, well you've just lost all of your calculation then, right? You just had it almost the same, right? 0.04 to the power of 4. Okay, right. All I changed was that 5 to a 4, right? Getting closer, right? Problem is a lot of people do that. Once you've got an answer like this, and let's say I just want to check that in 3 years, it's not even closer to 7,000. Well, what most people do is they clear and they start again. If you push the arrows, you can go back and edit it. So you made a mistake. Okay, well, let's get rid of that 4 and let's try instead 5 again, or 6, okay? Right? So by pushing the arrow key, I can just go back quickly. Delete, edit it, let's try 3 years. Okay, too little, so I need to be more than 3 years. Let's try 4 years. Okay, so 4 years is the best one. But if I just go straight in n equals 4, as someone who marks exams, I might look at that and be a little bit suspicious as to just go, well, how did you get that? Well, this is where it's about setting it up correctly. Set it up correctly up until now. Now I've just got to say what I'm doing. Guess and check. So, n equals 5 was my first guess. And so again, using my arrows, I can just quickly go back and edit it to figure out what that was. 7,000. So when n equals 5, the amount I ended up saving up was 7,299.92. So it was close, but it wasn't right. Okay, let's try a different guess. Maybe we think, okay, we're pretty close. Let's try 4. So n equals 4. My final amount was 7,019.15. So we're pretty sure it's going to be n equals 4, but we have to show that it's not n equals 3 or something even smaller. Because right, you imagine you're saving up for a trip, you want the smallest amount of years. So once again, arrow key, change the 4 to a 3. And tick. So it's going to take 4 years for us to be able to do it. So whenever you're guessing and checking, if you do not specify that you're guessing and checking, not paying it, if you don't show me a few tries, there should be probably one where you're pretty close, one where you're a little bit under, and then the one that you really want. And if you use the arrow system to guess and check, I promise you it will save you a lot of heartache. It does take a lot of the effort out of it. So this time I'm going to give you quite a similar question, a little bit different though. So I'm going to give you $6,000 and I want you to turn it into $7,000 just like before. But this time I want you to do it if you've only got a 2% per annum compounded yearly. Okay? So there's your question to have a go at. See if you can work out what the n should be. Okay, let's have a go. P-A-I. Make sure you pause the video. Don't skip ahead. A is equal to P1 plus I. Substitute in 7,000 equals 6,000. 1 plus I. Oh, I didn't put an n up here. That probably doesn't help. Not I. 0.02 to the n. Okay. Now I've got to set it up correctly. Now I never start writing down my guesses until I've actually found the answer. Now that may seem like cheating, but it's because if I have to write down 20, that's going to take up a lot of time. It's more quickly to get close and then fine tune up. So let's start off just by getting close. So 6,000, 1 plus 0.02 to the power of something. Well, let's try 5 years. It was a good place to start last time. So 5 years, not quite close enough. I'm not going to write that one down. We've got to get a bit closer before I'm going to write down 5. Let's try 8. Okay, 8's looking pretty good. 8 years is almost there. So let's try 9. Oh, well, let's try 7, see if 7's any better. Okay, 7's a little bit under. So I'm pretty sure 8's the right answer. But one guess and check isn't good enough. So I do need to show my process. So in this case, because I only tried 3 numbers, I'm probably pretty safe to just write those 3 guesses down. What you always want to make sure is that you show that it's the fewest years in which you get over that amount. So that means we're going to just show a few of them. So I might even do n equals 8. I know, oh sorry, n equals 9. I know n equals 9 doesn't work, but it shows my process nicely. Right? Yeah, that one doesn't, you know, there's better ones than n equals. In fact, n equals 8. We kind of know 8's the answer now, and now we're just kind of filling in the blanks. So that's looking really good. And now all I've got to do is do the one where it was one smaller. Again, use these arrow keys. You're going to make your life so much easier. Tick, done. 8 years. Alrighty. So that's how to do guess and check properly. One problem though, if I change those compounding periods, it's going to mean that our information is a little bit different. And it means my answers are going to be a little bit different as well. I'll show you what I mean. So, I'll keep it much the same. $6,000. I want it to become $7,000. And I talk to the banks and they say, Mr. Kettle, best offer we can give you is 4.8% per annum. And like most banks, they compound monthly. Okay, so it's no longer compounding yearly, means a little bit of funny business does need to happen. Alrighty. PAI, I've got to convert from a per year to a monthly. I'm going to divide it by 12, which is going to give me 0. I think it's 0.4, but I got it wrong last time, so I want to make sure I get it right. 0.4% per month, which is really as a decimal 0.004. Lots of zeros. So now I can go back to my usual strategy. A equals P, 1 plus I. Alrighty, so set it up. Now I've just got to once again, I'm not going to quite do it just yet. I'm going to test a few before I even get close. And these ones tend to be a little bit harder. So let's try 10. Yeah, 10 barely made a dent. Why? Because that's only 10 months. That's not even 1 year yet. So I might need to go a fair bit out. Let's try 40. Okay, 40 was pretty good. That's 40 months. That's pretty close. But because we're doing it in months, it's going to take a little bit longer to fine tune it. So let's try 38. 38's too small. Okay, so I was actually pretty close. Let's try 39. 39 looks like the money shot. Okay, so 40 was too many. $39 looks pretty good. $38's a little under. Okay, so it looks like 39 is the winner. But I'm not just going to write down 39, I'm going to write the one above and the one below. So 40, 39, which I know is the right one, and 38. The great thing about this as well is if you use those arrow keys, brilliant thing happens. To write down the values, you're not having to retype it every single time. You're only changing one thing about the equation. So that should reflect in the fact that you're only changing one thing. You shouldn't be having to retype the same thing every single time. The calculators are smart. Alrighty, so $7,010.78 for 39, and we know 38's a little bit under, so just underneath 6,982.84. So not quite up to 7,000. So cross, cross, tick, and the only difference between the previous one and this one is that I do need to say that it's going to take 39 months. Right? Some of you might want to think about, well, how many years is that? And that's probably a good idea too. But I want you to really focus on the fact that you've got to think about units. As soon as we're out of yearly, the units kind of matter. Is it a monthly or is it yearly? Alrighty. So I'll give you the same question. $6,000, $7,000, 4.8% per annum, compounded, and this time let's go for weekly. Remember, 52 weeks in a year, so you should be probably putting a fair few numbers in before you're going to find it. Pause the video, have a go. Alrighty, so same as the first one, my interest rate is a yearly interest rate, and I need it to be a weekly interest rate. So 4.8% per annum. I need it to be weekly, 52 weeks. We get a very small interest rate, 0.092% per week. Now, once we've got that, the rest of it is our P, A, and I. And this is where you've got to be really careful, because I got 3 zeros in a row, because it's already 0.092%. Now I've got to turn it into a decimal, so it becomes 0.000292. So you just got to be really careful on that. But once we are here, time to guess and check. And I'm gonna guess if the other one was a little bit more than 3 years, we're probably going to be looking a little bit more than 3 years. But in terms of weeks, that's going to be a big number. So this one might take me a little bit longer. Let's have a go. Alrighty, so 6,001 plus 0.00092 to the power of, let's just say 100. Why 100? Well, because there's probably about 100 weeks. Well, 100 weeks isn't even 2 years yet. See, we're only like $500 way through to get. So we need to probably go, let's go 150. Okay, 150 is getting closer. It's about 3 years. 200 we should be good. So 200 should be our upper. Okay, so 200's over. So we're good with 200. We can go a little bit back. Let's try 180. Let's work out which 100. Okay, so 180 is a little bit above. Let's get a little bit closer. Let's do 175. 175 still above. Okay, so I might need to move even closer. 170, still over. 165, just under. Okay, so that's a really good point. I was kind of going down in fives. 170 was over, but 165 was under. That's a good thing. Okay, so we're getting close. So let's try 168. Just over. $2 over. That's almost perfect. Let's try 167. And 167 is just under. Perfect. So 168 seems like it's our winner because it's $2 over. That's with, can't see it, but it's 168. $2 over. Okay, so 168. Let's say our first guess was about 170, and then our second guess will be 168, and our third one will be 167. Okay, and once I've written down these ones, we are good to finish up this. So let's try 170 first. Let's remind ourselves what it was. Pretty close, $15 over. Already written A. 7,015.26. 68 takes us down to $7,002.37. And the last one, we've just got to check the one underneath to show that there's not a better answer. And this one was 6,099.93. That's our final answer, which is 168 weeks, because units are important. So it's a little over 3 years, right? 50 weeks in a year-ish. It's about a bit more than 3 years. Alrighty. That is how to solve for the compounding period. And that is the last of this stuff. Alrighty. Good work, everyone. Been 3 pretty tough lessons in a row. Hope you're finding it pretty okay. Let me know how you go. Alrighty. See ya. Bye-bye.